Good afternoon. Thank you for joining us. You still have time to tell your colleagues by WhatsApp or call them to come in and join us as well. There's some spaces. I am happy to announce that this is the part of the Industrial AM by Mobility Gets Additive. It's my honor to introduce our moderator, who is the Managing Director of Mobility Goes Additive. Please, a round of applause for Stefanie Brickwede.
Thank you so much for the very kind introduction. Thank you. Now we're here in the industrial panel, and I'm really happy to welcome you, and we will have a great range of speakers. And I will be happy to introduce them one by one. And the first step, I would like to explain to you what Mobility Goes Additive is. So one or another might have heard about it. For the others, I will show you a short presentation. So, perfect. You kindly introduced me. So I'm also not only the Managing Director of Mobility Goes Additive, thank you, but also I'm responsible for additive manufacturing within one of the biggest railway companies in Europe. But from that side, you will learn more by my colleague Tina, who will shortly be presenting after me. Last year, we've learned from a well-known study from the ING Bank in the Netherlands that 50% of all parts worldwide will be printable by the year 2040. This is really amazing. And if you think about that you could print half of the parts, whatever you think about, in additive manufacturing, you can see the potential is really huge. So how about the different sectors if it comes to industrial additive manufacturing? You might have seen some of the parts by the aviation industry. GE has printed a whole range of parts for Boeing. Airbus is one of the key players in Europe when it comes to additive manufacturing. What do they want to achieve? They want to reduce weight. And each kilogram within a plane, multiple by 25 years of operation, is really pure cash out if they can save a kilogram of weight. And with this perfect technology, you can reduce a lot of weight. And you might have strolled around in the other area at Healthio. You will also find some brilliant use cases for the medical sector. They print already implants for different use cases. You will have a lot of orthesis, prothesis, and whatever. And the medical sector even thinks about printing organs. And this will be a huge step if it comes to mobility for human beings. Also, not only the aviation industry, but also other industry like printing is definitely rocket science. And you can print already a lot of parts for this use cases too. Makes it really interesting. So you might have learned from Elon Musk, the founder of not only Tesla, but also a rocket company, that they print a lot of parts for space. And we had a great event 2 weeks ago in Berlin where we learned about printing with powder bed technology in space for the next Mars mission. So this will also be possible in the future. And we are already working on that. And furthermore, also the machining producers start exploring additive manufacturing for their purposes. There you have a lot of use cases. And also, for instance, in the construction equipment branch, they are just discovering what to do and how to help their spare parts business with additive manufacturing. The automotive companies still have a little problem because if you think about additive manufacturing for a Volkswagen Golf, the technology is still a bit too expensive. But for classic cars, for trucks, for buses, they're already exploring a lot of spare parts in general, which can be printed. And since I'm coming from a railway company, you will find a lot of use cases already there. And not only by the Deutsche Bahn, also the Austrian railways, for instance, and you will have the great chance to listen to Felix Spies after Tina, who will explain what the Austrian railway company is already printing. You can prolong life cycles with additive manufacturing. And if you see such pictures like that, it's really breathtaking when Industry 1.0 meets Industry 4.0. And this is really interesting so that you can prolongate life cycles of machines or high investment goods with additive manufacturing. This is also a very interesting use case from the automotive industry, which is used in a car. Usually, if you have a car crashing into a human being in an accident, you will severely damage those people. And with the help of this part, you can take the energy from the crash and save humans' lives. By additive manufacturing in such shapes you can see here, you could never ever produce with another technology. As well as I've already talked a little bit about the medical sector, you can do a lot of implants already, and this will increase in the upcoming years a lot. And what's fairly new is that you can also print huge metal parts. And I've studied economics, I'm not an engineer. So usually if you compare costs by different technologies, milling or whatever, you would come to the conclusion that big metal parts from an economic point of view are not worth doing those. But now we have the technologies with which you can do this. This is printed by a company from Berlin. It's called Giffertech, and they have a wire arc technology, which means every metal you can produce as a wire, you can have printed. And those are two of the most important technologies which are used for spare parts at the moment. You have on the left-hand side the FDM technology. It's a fused deposition modeling, and which you can use for tooling purposes, for instance. And on the other side, you have the selective laser sintering or melting, which is used for a lot of spare parts. And if you take a look around in this arena, you will find a lot of use cases there. And this you can also see over there, the technology of HP. And this is also a very promising technology where you can print spare parts made from different sorts of plastic and bring them in the locomotives, trains, also cars or whatever. There are some new technologies coming up at the moment. I've talked already about the wire arc technology, which allows us to print huge metal parts and use them for industrial purposes. But also the scanning technology is improving a lot. So those people under you who like the Star Trek logic, where you push a button and out comes a replicated spare part, this is coming to reality right at the moment. So over there you can see a scanner where you put in your part to scan it and have it printed afterwards. You can produce even an STL file with this. So it takes a scan in much less than 1 second. And afterwards you can print it by, for instance, FDM technology. Yeah, but where we are at the moment. So a lot of people always talk about the Gardner hype cycle. And it's really amazing if you take a look at those Gardner hype cycles from year to year. You can see that there are many, many more use cases, niches, and branches entering additive manufacturing. And what really amazes me is that I thought 3D printing, for instance, for medical devices, has already, the truth of disillusion, the truth behind it, and they are already on the slope of enlightenment. But if you take a closer look at certain technologies and certain things you really want to produce, then you might come to the conclusion that for different niches, they are starting again with the innovation trigger. And this is not a bad sign, it's a really good sign, because there are so many sectors discovering additive manufacturing and using it and getting to the innovation trigger and to peak of inflated expectations with their certain use cases. And 3D printing definitely can open new horizons. So many companies often ask me, we want to start with additive manufacturing. What do we have to do then? We've seen a motorcycle, and we would like to print something like that in metal with a different kind of shape, topology optimized. How can we enter this? And I always say, do you really want to search for the Holy Grail, or do you want to start with something simple? And I would always suggest to start with something simple, because the Holy Grail is still waiting for you. So to think about intelligent algorithms, there are so many promising companies which already take this into account, and you can use their services already. And they produce with this intelligent algorithms already automated prices. So you will find also some platforms where you can load up your printable files, and they tell you exactly at that moment what the costs will be if you want to have it printed. You can do a data bank screening. We also try to do this in different companies, and it's not really easy, because usually the information needed to decide whether a part is printable or not, you don't find those criteria in your data banks at the moment. So you need some more data, but those screen processes are improving too. And afterwards, of course, sometimes you want to do a part optimization and to bring different functions together. This is one of the big advantages of this technology, and then it's really worth thinking about changing the shapes and the geometry of those parts. But if you really want to start fast, I would say look for the simple plastic parts. Don't take the very complicated ones in the first step. Proceed with metal parts so that you can have some experiences and you can use the biggest advantage of this technology. It's a haptical one. You can give printed spare parts in the hands of your colleagues and employees. And therefore, they will experience the advantages by feeling it, by touching it. And this is one of the experiences we also had with our boards, our decision boards. So also the CEOs of huge companies had the advantage to get in touch with the real production. Normally, they've lost this contact quite a while ago. But therefore, they can touch their product again. And this is what really produces a lot of enthusiasm in such levels. Yeah, you can copy those parts. And I would also recommend this. If you go to congresses in additive manufacturing, you will always find brilliant experts. And they will usually tell you, you have to think totally differently from everything you've done before. And you have to think about totally different designs. You need designers who are capable of getting all the advantages out of this technology. And then if you're just about to start, you say, oh my goodness, where can I find those people? And what are the right use cases? And what can I do? And what kind of technologies should I use? And then you're getting like this. I would like to encourage you, it's totally okay to use the simple parts and just to do one-to-one copies. And this is what I usually call mutants. Afterwards, you can also produce customized parts. What you see here is one of the examples of the shoe production industry. This, for instance, is Under Armour, but you can also find different examples from Adidas, Puma, Nike, you name it. And what they do is they produce different shapes of the soles. And so those soles have a different reaction when you're walking on those. And then the further step, they will do this individually for your weight, your kind of walking, and so on. And if you've gained some information, if you've gained some experience with this technology, you will automatically come to the mutants. So the topology optimized parts, where you only use material where you really need it. And the longer you're in this technology, and I'm in this technology now for 3 years, you will see so many developments also concerning software where you will be able in future just to press a button and you get a topology optimized part. So this will be very helpful if it comes to such structures. If you talk to printing service bureaus, from time to time they are a bit disappointed. Sometimes they think there must be such a big potential. Why can't we get this in the first step? We've bought already 3 to 4 machines, powder bed machines, which are quite expensive too. And so they would always ask, why does it take so long? And I always say, first you print some parts, then you have to take care of the standardization for your processes. And this takes a while because the people in companies who do the screening of the parts are usually the same, which have to think about the standardization processes. So this will lead to a structure which is more like this. Yeah, and I can only recommend find like-minded people, and the cake we are talking about is really huge, so you can share your experiences. And this is what we also do within Mobility Goes Additive. You can think about approval, education, new technologies and digital support, the legal framework, save a lot of money and time, and have a development of materials together. And think about how can we support the change management in companies. And we've also founded an IIM hub in Berlin, not in Barcelona, but in Berlin. And if you want to, we can talk about this later on. Yeah, we founded this network 2 years ago. Now we have more than 85 members. So you can see we are just going with the waves. Thank you a lot for your attention. And yeah, I'm really looking forward to our discussion later on.